All right, hello, welcome. This is building an end-to-end serverless app with machine learning, data, serverless, all the buzzwords you can fit into a title. They're here. So well, it'll be a kind of a fun journey through a bunch of serverless tools at Google Cloud. My name is Brett McGowan. I'm a developer advocate for serverless on Google Cloud. And what that means is I just would love to hear what you're doing with serverless, what you're trying to do with serverless, what's working well, particularly outside of what's traditionally a service or the functions as a service, these cloud functions. These are kind of the three guiding principles that I like to think of, and that's sort of what I'll use when talking about what is serverless in Google Cloud. So we've got invisible infrastructure. So you're not worrying about managing clusters or virtual machines or networking, all that stuff. That's kind of handled for you. Scaling up and scaling down is transparent, and most importantly, scaling down to zero, meaning when your code isn't running or your query isn't executing, or your machine learning model isn't actually training or doing prediction. If it's not doing something, you're not paying anything, except for storage. But generally, as these systems sort of go to sleep and they wake up, your billing is tied very, very closely to that. So these are sort of the guiding principles as we talk through this. And we have a lot of tools for serverless on Google Cloud. We're actually going to touch on all of these categories, from data analytics to compute to machine learning. We don't have a lot of time, so it's just going to be a little bit about a lot of things. I have some other resources. You can dig a little bit deeper into a specific example that we're looking at today to kind of see how all of these pieces really tightly fit together. But as you can see, there's a lot of tools at your disposal when you talk about building a serverless application. And rather than kind of walk you through it product by product and give you the pitch sheet, I thought, let's build something. Let's actually build a complete end-to-end serverless app. And we're going to do it because in my imaginary startup, I have invented a way to do mail order ice cream. And that's going to be the example we have in e-commerce. And actually not just any ice cream. It's going to be specifically soft serve. If you don't know what soft serve is, it's this kind of ice cream. It's not like the hard ice cream that you necessarily get in the freezer. It kind of comes out of a big metal machine, typically. And it's actually not just soft serve. It's actually going to be soft serverless ice cream. And you were thinking, Brett, did you just come up with this whole idea because you had this goofy pun? Save your questions till the end. It's not relevant. But definitely, yes. So we're going to have this example of a soft serverless ice cream shop. We're going to sell ice cream online. We've got all your classic flavors like blueberry a la node, pistachio. Sorry, it's going to be one of those sessions, so bear with me. All right. And there's a lot of pieces actually behind making a full, production-ready, scalable application. And this is a lot to take in, so we're gonna break it down. We're gonna do it piece by piece. We're gonna do it in 4 parts. First will be serverless fundamentals. What are functions? What are apps? When do you use App Engine? When do you use Cloud Functions? We'll talk about serverless outside of just compute with some machine learning and some big data. Then we'll talk about serverless outside of Google Cloud platform specifically. And then some things about what does it take to run serverless in production. And again, we're going to just kind of touch a little bit into each of these topics. So I encourage you to follow the link that I'll show in a second. You can dive a little bit deeper. So first, serverless fundamentals, building with functions and apps. This is an e-commerce site. We have a web app. And so in our sort of traditional app model, we've got the presentation layer, which is going to be a web app. It's going to be a Python web app running Flask. And if you don't know what Flask is, it's just like a web framework for Python. It's like Express.js if you use Node. The point being is there's nothing particularly specific about Google Cloud. This is what you would run as your web framework no matter where you're running your Python web app. And what does our presentation layer do? It does things like shows you the cart, shows you the products that you can shop from, right? It renders the HTML to talk to the user. And then from that, we've got some services that are going to be backing this presentation layer. And those are going to come in 2 categories. They're going to be synchronous operations. So things like, what does this cost? Or what is the image for this? And these are synchronous in the sense that when I ask the service for it, I want to get the data back right away. So I need a response now, and I'm going to actively wait to get a response. This is in contrast to asynchronous ops, where the request comes in, and maybe it's a long-running app. Maybe I need operation. Maybe I need to do some complicated data analysis, or I need to do some long-running query, or whatever. So the service will tell the presentation layer, OK, got your request. Thank you. I'm terminating this connection. I'll get back to you later, right? So that's the asynchronous operations. And these are things that aren't as time critical. So if I want to do automatic categorization of my products, or maybe a payment process, like I don't need to, if my payment processor is down, I can't make the end user wait until the payment processor comes back up. Like I'll take it, accept it, we're all good, acknowledge the request, and then handle it later. And then the third layer is going to be the data layer. So this is our database, essentially. This is going to take a list of all the categories that we have, all the products that we have, all the metadata, the pricing, promotions we're running, have people's orders, carts, all that sort of a thing. So now we're going to walk through how to choose which pieces of which when we're building our serverless application. And the first is going to be serverless data. And I like to classify serverless data on Google Cloud Platform into 3 broad categories. So there's data for your application. So this is a database that actually runs your app. So in this case, I'm actually inserting orders into the table. I'm querying to see what products meet some sort of query that I'm querying on, right? My application actually runs on this database actively. Second category is an analysis, so data warehousing. My app doesn't actually run on this database. Data gets fed to this, so I can do reporting on it later. I'm not reading and writing and deleting and modifying all kinds of rows. It's conceptually just like a write only, just dumping data into it. This is sort of the big query. And then data flow, which we won't really get into this talk, is when you need to manipulate your data, like as it comes in batches or it's streaming, you need to clean it, you need to process it, you need to do some complex work on it. Data flow is a good sort of serverless tool for that. But for our app, we're going to focus first on Firestore, which is our serverless database that we're going to use. It's NoSQL. It's a document-based database. And it has some really interesting properties. So it scales really, really well in a serverless manner, so you aren't actually going in there and tweaking knobs and setting up replication and backups. That's handled for you. It's a really cool property of real-time updates. And what that means is as your data gets changed in the database, Firestore actually is synchronizing those changes out to all the clients potentially in real time. So if you have 100 people on your website and a change gets made to, say, a price, Firestore can actually push out all of those changes to the clients in real time if that's what you want. And then it's serverless. So again, going back to serverless pricing means if you're not actually querying the data or reading or writing, you're not paying anything except for storage, which is fairly minimal. So it scales directly with how you use it. So that's data. So it's going to take care of our last column, which is the data layer. So now we're going to move into compute. And this is where things start to overlap a little bit, I will admit. So hopefully we have some guidance, I can get some guidance on how to choose what. So the first is serverless functions. This is sort of where my heart lives. I love cloud functions. I've been working on it for several years. And this is event-driven, sort of single-purpose functions that run in the cloud. So a file is uploaded and I want some code to run. Or a document is changed in Firestore. I automatically want a cloud function to run. So just think events that happen in the cloud, and your code runs in response to it. And Google Cloud takes care of wiring it up and scaling it. And then down, we've got serverless applications, and that's just kind of what it sounds like. So this is outside of just one single-purpose function. This is an entire application. So an entire web front end, an entire API. So this is internal routing you're handling state inside of your application. This is, App Engine is a good product for that. And then the newest is Cloud Run. And it's also sort of serverless applications, but it could also be functions because it's wrapped in a container. So it can be any runtime you want, any framework, or any language. Now let's dig in just a little bit. Why would you choose Cloud Functions? So I talked specifically around events. So if you have events you're responding to in the cloud, Cloud Functions is every time that function gets invoked, it will have 1 gig of memory. There's no sort of shared requests across an instance. You can also have it automatically handle retries. So in our payment example, if the payment processor was down and your function bombed, you could have Cloud Functions automatically retry it later. Languages it supports, Node, Python, Go, and then Java is coming. So again, functions, Cloud Functions. Now why App Engine? So in this case, we're talking about a web application, and App Engine is a really good fit for that. It's designed for web applications and HTTP applications like APIs. And part of that is it scales really, really quickly. Much better scaling characteristics, for example, than Cloud Functions, which is good for your user-facing web application. Because if the user has to wait a quarter of a second extra or a second or 2 seconds longer, that can actually turn into lost revenue specifically for you. So you want it to be as responsive as possible. It supports custom domain names. So obviously, if I have a public e-commerce website, I want my own custom domain, which App Engine supports. And just a little bit of a word about scaling. So why is App Engine scale faster or more quickly than Cloud Functions? And that's because App Engine allows for multiple concurrent requests. So that's good and bad, depending on your perspective. It's good because if you have one instance that's handling a request and another request comes in, it'll send it to that same instance. So it doesn't have to spin up another instance and create kind of a brief cold start, a brief delay. And so you could have it handle 5, 10, 50, 80 simultaneous requests before it needs to spin up a new instance. So that's good. That means it can scale to handle a ton of requests really, really quickly without a lot of cold start. But the downside to that is it's shared resources. So if you have one request on that instance that's taking up a ton of memory, it could potentially impact the other requests that are coming in. Cloud Functions, on the other hand, is one concurrent request per instance. That doesn't mean it always spins up a new instance every time a request comes in, because it might have a still hot instance left from a little bit ago, and it'll route a request to that. But you can know that if you asked for, say, 2 gigs or 1 gig or 512 of memory, you have it entirely to you for that one request. No other requests are sharing that instance. So now that we've kind of walked through that, let's go back to our diagram, and then we'll see a demo. So here's our web app. Between Cloud Functions and App Engine, probably not surprisingly, we're going to choose App Engine. It is designed to be a really good web front end. And then let's get into synchronous operations. So again, these are things that we're asking for some data and we want it back immediately. So here we actually have a bit of a decision to make. We could use Cloud Functions. They have HTTP endpoints. You can make a request. It will return a response. But actually for this, we're going to also use App Engine. We're actually just going to have services within App Engine, so it'll scale with our application. It's a bit of a monolithic approach, I know, but it works. And I think actually it makes a lot of sense because you have kind of some shared state across a user object and carts and products, so it can live within one shared code base in your application. So let's see a demo, if we go over to the demo machine. All right, so here is our live website. Soft serverless ice cream shop. We've got Softy, our raccoon. He's our mascot. We've got all of our classic serverless ice creams, banana as a service split, warm start apple pie. So we're going to, using App Engine, we're going to add a new dessert. And let's choose, we're going to do an ice cold start. Iced cold start. Your morning coffee served within 2 seconds. Let's see, how much will this be? This will be, it's coffee, so it's expensive, $6. So hit OK, and because those are all synchronous requests, as soon as the page comes back, it's in the database, the image is uploaded, everything is good. And if you just want to see, if you don't believe me, in Firestore, go down here, let me refresh. Here's our Firestore database. Uh-oh, there we go. Oh, it's not sorted. So somewhere in here, clearly it's in there, ice cold start, $6. Cool. So not a lot to it. I just kind of wanted to show you the app, and then we'll build on it as we go. So we can go back to the slides. So now we're going to talk about asynchronous ops. And so for this, we're going to use Cloud Functions plus PubSub. And if you're not familiar with PubSub, it's a message bus. So you can just send messages, arbitrary messages at it, and it scales up to incredibly high throughput, so up to millions of requests per second. And this could be any arbitrary JSON payload, sort of whatever you want to send to PubSub in sort of message. And it has topics you publish to that multiple subscribers can subscribe to. So I could publish one message to say new order or payment completed or whatever, and whatever subscribers you want on the other side can listen to it. And you'll see why this is useful in a second. Because traditionally, if we were to do payment processing in our web app, it might look something like this. We take an order, we process it, we kind of clean up the data, we normalize it, we do some sort of checking, we send it out to get processed as a payment, and then we send the user an email. And that's great, like this has worked for a while. But this has a couple of issues, one of which is, what if there's an error, say, in the confirmation email getting sent, right? And so we need to retry this. Well, now you somehow have to piece together, did I finish processing the order? Did I already send this payment out to get processed? I'm not sure. So instead, what you want to do is break these up into multiple sort of microservices, if you will. And we're going to glue them together with PubSub. Now, PubSub will let you do things concurrently. But in this case, we actually have a specific order, right? We need to clean up the data, we need to process the payment, and then we need to send the email. And we're going to use PubSub to connect these, to publish the message, so that, again, if, say, the confirmation email fails, we can just retry that without having to double charge the customer if we retried the whole job. But because we're using PubSub, and you can just connect any arbitrary cloud functions or any HTTP applications to it, with minimal effort, we could do some other things, like maybe we want to capture those order analytics and put it into BigQuery, which we'll see in a second. And none of the rest of the application has to change. We literally just added a new cloud function listening to the same topic that was already getting published to, and it's just going to take that data and put it into BigQuery. So more concretely, here's our App Engine presentation layer. It's going to publish the order data. So here we've got a topic called process payment, or payment process. We have metadata about the order ID, so we could pull it out of the database. We're using Stripe for third-party payments, so we're going to include that token in the message, because we don't want to persist it to disk. And then that's going to go to a cloud function. There we go. A cloud function that will send it to Stripe for payment and then update it in Firestore. But because we're using disconnected with PubSub, we're going to have that then publish another message to PubSub saying, I have completed the payment, it has been successful, this is what that looks like. Another function picks that up and then sends it to SendGrid to send a confirmation email that, hey, order was successfully processed or not successfully, as was happening to me this morning, and hopefully it doesn't happen in a minute. All right, so speaking of, let's go back to the demo machine. So let's see that in action, what I just saw. We're actually going to do a payment, so let's buy this, what do we want? Peanut butter and Jenkins. That sounds good. And I'll put in my address, so 123 Main Street. This is not my actual address, by the way. I do live in New York, so that is real. And this is my spam account, but please don't email me. All right, so my phone number. And if everyone will look away, I'm going to put in my credit card number. All right, and hit pay. So what has happened now is it's asynchronous, right? So the application immediately took it, returned back to the user, thank you, got it, published a message to PubSub, but the order isn't necessarily actually processed yet because it's all happening asynchronously through Cloud Functions. But if it happened quick enough, I should be able to come in here. Oop, thank you for your order. Awesome. And I didn't put any text in there because I'm lazy. But two functions got triggered, right? One to actually process the payment, and then one to send the email. All right, if we can pop back to the slides. And then another example, which I won't do as a demo because I don't think we'll have time, is a reminder. So we've all been to those websites where you add a couple things to your cart, but you don't actually check out, and then they send you an email a few days later like, hey, still interested in whatever? Like, click here. It'll be super easy. So with Cloud Scheduler, which is just cloud in the cron, you can set up these arbitrary schedules to say once a week or whatever. So in this case, we would say maybe every Monday at 9 a.m., go find any cart that hasn't been touched in a week that we haven't sent an email about already, gather it up, and send the person an email as a reminder. And we'll do it using Firestore to query the database and SendGrid to send the email. SendGrid, I guess I didn't mention, not a Google product. It's just a third-party emailing system. But it's super, super easy just because they have an API. So you just make a REST call, and you can send your email. Cloud Scheduler, if you don't know, like I said, it's cloud cron. So arbitrary schedules. I want Monday and Thursday at 3 a.m., or every 30 minutes, or every 1 minute. I want you to do something. You can do tasks within App Engine. You can have it published to PubSub, or you can make it an invoke in HTTP function. So in this case, we would have it call an HTTP cloud function to send that email. But if you have some third-party system or some system running elsewhere that has an HTTP endpoint, then Cloud Scheduler definitely can hit that on a schedule. All right, so that's our compute. Now let's move beyond into the world of serverless machine learning. So we have an idea. What we want to do is we want users, because obviously we're going to be super popular and we're going to have thousands and thousands of these hilarious ice creams on our store. We want users to actually be able to browse by category. But we don't want to have to manually categorize these necessarily. We want to also automatically categorize them, say, based on the image. So how would we go from an image of an ice cream to some labels? Well, as is required by Google law, I have to involve machine learning in my talk at some point. So we're going to use machine learning. So the first, we're just going to use the Cloud Vision API. You've probably heard of it, but if not, it's just an API. It has been trained with using machine learning, but you don't use machine learning in any way. It's just an API. You call it, you give it an image, and it analyzes it, tells you like what objects are in the image, what is it an image of, colors, things like that. And there are various APIs for text and language and translation, text-to-speech, a whole bunch, video processing, a bunch of these. So that's going to be the first part. This is going to be an easy part. We just give the image to the API. It comes back with these categories: dessert, ice cream, sundae. But there are more specific categories that I want to use that maybe the Cloud Vision API doesn't know about. So maybe specifically I want to have it labeled like blueberry ice cream or mint ice cream or cookies and cream ice cream. And actually Vision API does know about some of those, but it doesn't know about all of them. So with a tool called AutoML Vision, I can actually feed it a bunch of images to train it. This is what mint ice cream looks like. This is what cookies and cream ice cream looks like. Minimum of 10 images. We recommend 100 or more so it really can get a sense of how to categorize these. It will create an HTTP endpoint for you to invoke. And it's serverless because when you submit all the images for training, it spins up enough resources to do all the training based on the images and the labels you've given it. Once it's done, it spins down to 0, so you aren't paying for it. And then when you do predictions, similarly, it scales up to handle the amount of predictions you need. If it's not doing any prediction, it scales down to 0. So how do we actually use this? So we've got a presentation layer. We add a new item. It's going to publish a message to PubSub, say new topic. We'll have two functions. The first function we'll just call the regular Vision API, get those labels back, and then save them to Firestore as categories. And then the second one will do the same thing, but using AutoML Vision. So these are our custom labels that I have trained this on to recognize blueberry ice cream or cookies and cream ice cream. All right, so let's actually see these in action. If we can head back over to the demo machine. All right, so just to kind of show you what it looks like, so here are some examples of the labels I put in: blueberry, chocolate, cookies and cream, matcha, I don't know how you say that, not hipster enough, mint, strawberry. But if I click on these, then you can see, here's an example of some of the images that I used to teach it. Here's what strawberry looks like. And so one thing I thought would be interesting, here's mint, and it's kind of like this light green. That's like a very sort of neon green looking color. That's bad data. But then this matcha it's actually very similar. It's also green, like a slightly different shade of green. So let's see how well this does. So I just loaded all these images into cloud storage, and then gave them the labels and said all of these images are cookies and cream, and all of these are chocolate or strawberry or whatever. So let's have it look at, this one is a mint, and see what it comes back with, because those are pretty close. So you can see it's 81% confident that it's mint and about 18% that it's matcha, because they're pretty similar. So I think that was kind of interesting, and that's not necessarily something that the Cloud Vision API can do out of the box, so I trained it to do that. So let's see that in action. Let's add another dessert and have our custom machine learning label applied to it. I'm going to take, we're going to have one, and we're going to call this Kubernetes and cream. You can really taste the Kubernetes. Pods of chocolate. That's a little Kubernetes joke for you there. And that's going to be $5. And submit. All right, so going back to the synchronous versus asynchronous, you can see right away Kubernetes and cream showed up, but it's actually missing these labels over here, so food, dish, ingredient. But if I refresh, it actually was pretty quick. It was just a second. So the black one is my custom cookies and cream that it labeled, and then the others, the food, ice cream, and frozen dessert, are the ones that the Vision API did. So it actually happens like probably less than a second later, but if you think about it in terms of priority, it's okay for the label to come a second later. As soon as we get that product up for sale, that's the priority. We want that to happen in real time. So that was Cloud Vision API, and then AutoML. So if we can switch back to the slides. All right, so our shopping app can automatically label images and custom labels, but sort of what do we do with this data? How do we make sense of it? It's generating tons and tons of data, because obviously our website is getting massively popular. So we want to take all of that and we want to put it into our big data analytics warehouse, which is BigQuery. And this can handle to terabytes and petabytes of data. You query it using standard SQL. And so it has a compatibility with a ton of tools. So Data Studio, which I'll show in a second, Tableau, a bunch of reporting tools can talk to BigQuery because it uses standard SQL. So you actually can do things that you might not traditionally do, where normally you aggregate your reports, right? So your data scientists can look at it and take, and, kind of plunge and gain insights. You sort of roll things up. But with BigQuery, you can just put all of your data, put all of your web server logs in there, put every event that has ever happened on your website into BigQuery. And it will be able to query and join. You can get really interesting website insights when you go that granular. And I mentioned it plugs into Data Studio. So this is a visualization tool hosted on Google Cloud. Nice and serverless in the sense that I don't have to install anything or run any software. It plugs into Google Sheets, BigQuery, Cloud SQL, a whole bunch of other plugins, has visualizations, and you can also export it, embed it in presentations, and things like that. So I don't have a very interesting demo, unfortunately, but let's hop over here just so I can show you. So here's our table. I've cleverly named it, make this a little bit bigger, sorry. I've cleverly named it sample data, sample table, and it just has a bunch of events. So especially because we're publishing a lot of things through PubSub, it's really easy to have just a bunch of these little functions that also listen to those PubSub messages. Just take it and then insert whatever relevant data into BigQuery. So you can see, for example, I've been doing a ton of label detection, just label detection. There you go, payment processed. And then I have a very beautiful graph using Data Studio that just connected directly to BigQuery to get insights on what's happening on my website. I don't know if this is going to be big enough. Oh, it is resisting my efforts to zoom. That's nice. But down at the bottom, so overwhelmingly, I was testing some of the machine learning. That's why it's so much label detection. But order created, payment failed, payment processed. Again, it's just capturing all these events, and it's just streaming all those sort of clickstream events that are happening on the website. And BigQuery is able to handle it. It scales up and down automatically. It's a service. You don't have to provision any machines. And it can handle massive, massive data sets. In some cases, like terabytes of data you can query in seconds without having to set up any indices, having to do sharding, anything like that. Very, very cool tool. All right, we'll go back to the slides. All right, so now we're going to do serverless beyond GCP. Specifically, we're going to talk about Google Assistant, which we talked a little bit about this morning in the keynote. So Google Assistant, wildly popular. It's on over 1 billion devices at this point. So this is everything from smartwatches to iPhones to Android phones to computers, TVs, automobiles. There's over 1 million different actions, over 1 million different things that it can do. And it's over 25 different locales, so that's sort of languages and locations. And there are 3 parts to the Google Assistant. There's the physical device. This is the phone or the smart speaker or whatever that has the assistant built in. There's the assistant itself, and that's sort of where you directly talk to Google. So you ask it, and it knows things like, what time is it? What is the weather? Tell me about my calendar, things like that. But then there are these actions on Google, and that's where we come in as developers. We can create sort of custom things for our users to interact with using their voice with our devices. So I'm going to show you a voice interface for talking to our soft serverless ice cream shop. And how it works, so first you have the surface that talks to the Google Assistant. The Google Assistant decides, are they talking to me directly as the assistant, or is this something I can handle? And if so, it responds immediately. But if they're trying to talk to your specific action, or it's something it can't handle, it will reach out to your actions on Google, which consists of a couple of parts. I'm going to use a tool called DialogFlow, which we've talked a little bit about. And this is basically just for doing natural language processing, turning unstructured text into structured text. From that point, once it's figured out what are the things that you're talking about, what are the entities, and what are the intents, what are you trying to find out, then it will hand off via a webhook to your custom logic, which we're going to use Cloud Functions. And this is really nice, again, because it scales down to 0. So if no one's talking to your assistant, you don't pay anything, everything's asleep. As soon as a request comes in, it'll spin up that infrastructure. So we're actually going to talk to the exact same Firestore database to do a query, to be able to talk to our store with our voice. Just one slide about DialogFlow. Like I said, it takes unstructured text and creates structure out of it. So you can see just talking about, I want to play music, there's a lot of things that people can say and in a lot of ways that they can say it. So I could ask by genre. I want to listen to country music. I want to listen to rock music. You could ask for just a specific song, just a specific artist, a specific song by a specific artist. You can just say, play music. Now, if it was up to you to figure out which one of these are songs and which one of these are artists, which ones are countries or proper names, like that's a lot of work that may not be necessarily what you want to spend your time doing. So DialogFlow has a ton of these sort of entities built in to do intelligence around extraction. And also just so you don't have to get the phrasing exactly right before it hands off to your entity or to your custom logic. All right, so let's see a demo of this. All right, so here's my DialogFlow. So there's a few things here. Let me go to intents. And there's a few things I can say recommend. And DialogFlow actually has the ability that it can just respond itself without having to do anything programmatic. So here's some expressions I have, like what is your favorite? What should I get? What's good? What do you recommend? And I just hard-coded a couple of these, right? Like my personal favorite is blueberry a la Node. So if I say, what do you recommend? My personal favorite is blueberry a la Node. Looks like server is unavailable. I feel like it's actually just worked, so I don't think so. But we're probably more interested in doing custom logic, right? So we actually want to have extracted entities and intents. So I'm going to go over here to an intent that says product.list. So I gave it some phrases. Do you have gelato? I want to buy an ice cream. Look for a typewriter. This store used to sell hipster things. But maybe we're expanding our business, ice cream and typewriters. But the point is, it has intelligence to recognize, okay, do you have is not necessarily the important part of this. Gelato is. And I have it doing in a category, but it has a ton of built-in data types. So you can identify, for example, music artist, unit of weight. It has proper names, airports, times, locations. And it actually has intelligence. So if you're looking for a date, and I say, are you open on Christmas? DialogFlow will actually say, what is the next Christmas? Let me turn that into a proper date, so December 25th, 2019, and that's what will actually get passed to your function. So your function doesn't need to know, like, what does Christmas mean? It is going to get a proper date because DialogFlow will take care of doing that for you. And the exciting thing is you can actually integrate this. So now that it's actually extracted the entities and the intents into this category variable, we're going to hand it off to our webhook. So we have this webhook, which is running a cloud function. So let's see that in action. And as it does this. So there's a simulator for actions on Google, and you can do different, we call services. So a device that has a screen, a device that doesn't have a screen. And actually, I actually have a live Google Home here. So why don't we actually talk to it directly? Hey, Google. Talk to soft serverless ice cream shop.
Okay, here's the test version of soft serverless ice cream shop.
Welcome to the soft serverless ice cream shop.
What's trending?
Everything is trending in the serverless store.
Okay, well, what do you recommend?
I love Kubernetes and cream.
Do you have gelato? Maybe not.
PyCache.io, banan AASPLIT.
So the pronunciation may be a little bit off my ridiculous spelling. Let's see, what else do I want to ask? What can I buy here?
I missed that. Say that again.
What can I buy here?
Types of products available include food, ice cream, dessert, dish, ingredient, gelato, frozen dessert, vanilla, sundae.
Thank you.
Deserting me already? That's cold. Just kidding, you make me melt.
She's so snarky. So that was actually live querying our Firestore database. If I had gone in and I had renamed one of these in the database directly, like she would have immediately picked that up. And all she was doing is just querying and combining all the categories that were labeled from the Vision API and sending them back to me so I could filter with my voice. There's actually a whole SDK for doing transactions over the Google Assistant with actions on Google, with like collecting payment and creating a cart and all that. I didn't build that because there's like a lot more work that I wanted to do for a demo app. But there's a ton of tools available to do that. And I alluded to the assistant supports different surfaces. So in this case, in the simulator, I'm gonna simulate a phone, which has a screen and a browser. So if I say, talk to ice cream shop.
All right, here's the test version of soft serverless ice cream shop.
And so similarly, I can say, what do you recommend?
I love Kubernetes and cream.
All right, but if I say something like, do you have food, which before she just set out with her voice.
Machine learning matcha, mint Java chip, iced cold start, Kubernetes and cream, salted caramel cloud, blueberry a la node.
So you can see, not only did she say it out loud, but she actually sent me this little carousel so I could scroll through. Imagine this is my phone. Let me zoom in a little bit. There we go. So it actually, I can zoom in and I can say, oh, mint Java chip, perfect. I can click on it in my phone and it'll actually pull it up on the website on my phone so I can order it. So that way you can kind of take advantage of the different multiple services that are available to your users. You can also do things like, maybe I'm talking to the Google Home with my voice, and it could actually send something to my phone to get more information. So in this case, it could actually send me to the website where I can order this. All right, we can go back to the slides. Cool. All right, so the last section is going to be serverless in production, and then I'll take a few questions. So let's talk about security. By default, HTTP is open, right? There's no built-in security per se. So say we've got our user who is a bad user, and you can tell he's bad because it's red. And so he's malicious. And it's an e-commerce site, so obviously most of the site is going to be public, right? We actually want people to go to the site and browse around and see what's interesting and make purchases. But maybe there's an administrative portion, or there's some kind of payment page that we want restricted to certain users. So we need to make sure that this person is authenticated before they go to our App Engine app. So in this example, actually, I don't know if I said this out loud. I will put a link. This is on GitHub, so you can see there's more detail about like how to actually connect these pieces, the source code. You can build it yourself. My colleague Chen did a really great blog series that goes even to more detail about how to connect these pieces and how they all tie together. Firebase authentication is great. So it has a bunch of providers out of the box, everything from Google to Twitter, email, password, phone number, so you can have users just sign up with their phone. Anonymous, which is great. So anonymous is particularly great in an e-commerce perspective where I come to the site and I immediately get logged in, quote unquote, which means from the app's perspective, it's a user, they have an ID, they can add things to their cart, but they don't actually have to sign up. And this is a nice user experience because I can browse the site, get interested, add things to my cart, and then as I'm checking out, then you could prompt the user, hey, do you actually want to create an account? And then if they do, you could merge that anonymous account with their authenticated account through with their email and password or GitHub or whatever. And Firebase authentication makes it really, really easy. And depending on what you choose for authentication, sometimes it's easy just turning it on or off. Maybe you may have to configure sort of what the prompts of the user are as they go through the flow. But all right, our user is authenticated. We're keeping them out of keeping the bad users out of the sensitive parts of our site. How does this work from a code perspective? What does it look like? Firebase makes it super, super easy. There's SDKs that actually will do all the UI for you if you would like. You don't have to, but you can. There's actually this .sign-in with pop-up, and we have this provider here, which in this case is the Google login using their Google credentials. And Firebase actually takes care of the whole flow. Like it pops up a window, asks to authorize, they say okay, comes back, and then you get a callback in your web page that says, oh, the user's authenticated. And there are versions of this for iOS, for Android, and various other platforms. But you also get a token. So if you need to actually make an authenticated API call from the client, you can take this code token, call it to the server. So here's the server code. Firebase also has an SDK for parsing that JOT token, so you can decode it and make sure that this is a good user, that they're properly credentialed, that they have the right access. And then here's just an example of you can inject that as middleware in Express so that your app doesn't actually have to do this every time. The middleware will take care of it. So now we're going to talk about a couple of Cloud Functions authentication mechanisms for when you're actually sort of making this production ready. There's authenticating what can call your function, and then there's also authenticating what your function can call, right? So authenticating in and authenticating out from your Cloud Functions. So right now in alpha, there is what we call the invoker role, which is this, who can call this Cloud Function? Who has permissions to actually invoke it? So if you, once this goes live, things will be private by default, even if they're HTTP, unless they have the right credentials. And what does this protect against? So say our user, they're the bad user, they figured out, I can't get to the sensitive part of this web app, but I know there's an HTTP microservice on the other end. I'm just gonna go hit that directly. Because Cloud Functions, by default, if it's an HTTP endpoint, creates a fully qualified domain that you can access from anywhere on the internet. So unless you have it credentialed, anyone can hit that. And if it's a public API, that's maybe no big deal. But if it's some sensitive microservice, like clearly you don't want them to hit that. So you could set up credentials that only the service account that the App Engine app is running under has access to call that Cloud Function. So that way we close off that attack vector. Boom. As dramatically portrayed here. And then next is, what can my function do? And this went into GA yesterday, so it just happened. And this is, each function, you can create its own account and give it very, very specific permissions. And this is good sort of as a, the rule of least privilege for your code to run under. So in this case, we've just talked about, we locked down so that only the App Engine app can talk to that Cloud Function. But maybe we only want that Cloud Function to talk to Firestore. And for various reasons, like just maybe that function gets compromised, it has some node dependency that gets compromised, or some person is doing code that they're not supposed to. We can say that Cloud Function account only has access to Cloud Firestore, so if they try to do, for example, write files to Cloud Storage, they'll get denied because the account that's running under has been locked down. So one of the nice things actually about Cloud Functions and App Engine and Cloud Run is they all run under these service accounts. And by default, they are very broadly privileged, which from a developer's perspective is really nice, because click, 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 you just say connect to Vision API, connect to AutoML, connect to Cloud Storage, and all the credentialing and role, everything is handled for you. But it has the downside of, like, when you're in production, that service account by default can go to the entirety of your Google Cloud project. So they could be creating virtual machines, they could be spinning up GKE clusters to do Bitcoin mining or what have you. So it's important, like, as you sort of go to production, to make sure you lock these things down. All right, that is it. So the URL up there, bit.ly/serverless-store, that is the URL for GitHub that has like the blog post and all the sample code. Some of the code I showed here is not in the GitHub repo yet, but I'll have that in the next couple weeks. But that is it. Unfortunately, it was a sad end to my ice cream store. It turns out sticking an ice cream cone in an envelope and mailing it to someone was not a good business model, but the technology was sound. So thank you very much. And I think we have about 6 minutes for questions, if there are any questions. All right, see one coming up here. There should be a microphone there, yeah.
Hi, great presentation, thanks. So having all these different cloud functions and different artifacts together, what is your recommendation for like versioning? Say your front end is an API with a tight versioning scheme. How would you track that through all your different artifacts?
Yeah, so the questions are kind of around versioning and maybe APIs specifically. So I will say, so for Cloud Functions specifically, there is not versioning. So I guess there's versioning of the API, and then there's also sort of versioning of the code internally. And talking about versioning your API specifically, App Engine is you're going to have to use that. It's the only one that supports explicit versioning. It's nice because it also keeps previous versions of, so it's really easy to roll back. App Engine also lets you do things like deploy without promotion, so you can say, deploy this API, but don't actually make it the public URL yet. So it gives you sort of the staging URL. You can go test, make sure everything is good. I will say this, especially if you're trying to build an API on Cloud Functions and you have a bunch of these disparate pieces, there's not a lot of good tooling yet to actually track and manage all of that. I think that's kind of an active effort in sort of the broader serverless community anyway, just like how do you like get a hold of, it's a little bit easier from an App Engine standpoint when it's kind of this monolithic app that you can control all of it. But once you have, what we call function sprawl, and you've got maybe like 20, 30, 80, 120 functions, it can get difficult to know like, okay, this function, what is that chain, unless it's documented somewhere. So unfortunately, not great answers yet. There are some tools like Serverless Framework where you can kind of document in a YAML file and the workflow a little bit, but it's still kind of early days for those tools as well. So, yeah.
Cool, thanks.
Yep.
Hi, I'm Max Kenner, head of product engineering at Atrium, and my question is about custom machine learning in serverless. So for us, a lot of what we do is working on legal documents, and we have our own custom ML models. Some of those models may take up 1 to 4 gigabytes, and the model itself is larger than the memory limits on Cloud Functions or AWS Lambda, to be blunt. What is the serverless model there, where it's not just a matter of calling AutoML or calling Cloud Vision, but you actually have to deploy your own model, which is larger than the memory limit or the payload limit?
So you're talking about like real serious machine learning, like with TensorFlow and like data scientists have put it together. Yeah, so we have there's a couple of things there. One, we have a tool called Cloud ML Engine, which is designed specifically to be used for training and production of like your TensorFlow code, right? And so that is one option. I don't know if you've tried that or not. No. So that is like specifically designed for that exact case. So what AutoML does behind the scenes, Cloud ML Engine will do for you as part of your actual like written TensorFlow machine learning code. If you want a more like traditional sort of serverless approach, Cloud Run, which just came out, could be a good option. It's less serverless in the sense that you have to have a GKE cluster. Sorry, Cloud Run on GKE could be a good option because you deploy and provision your cluster, and that's just up and running all the time. But it does let you do things like you can attach TPUs or GPUs to it, so your actual machine learning code could serverlessly take advantage of some of the hardware that traditionally you can't do in like a Lambda or a Cloud Functions environment because that hardware is not made available. But you can customize the hardware in GKE. So if you use Cloud Run on GKE, you can customize machine sizes. It can be sort of you could have 64 cores with, 80 gigs that's a weird number, but a bunch, whatever, how much RAM you need. And so you can really like have much more control with the downside of like you have to manage a GKE cluster. But Cloud ML Engine I would check out, and then maybe just Cloud Run fully managed might also. I haven't actually done anything on that, but the GKE version should help.
Cool, thanks.
Yep. Yes. Yes, so the question's around CI/CD serverless. So there is I think a talk later today maybe about that specifically. If you go to this repo, we actually do use Cloud Build. I just build to deploy everything and to run unit tests and things. I just didn't have time to get to it in the talk. But Cloud Build is sort of serverless in that way, like it scales up to do in parallel to do your builds. It's still kind of early around that. People do things like with Circle CI and Travis that are like sort of these hosted. We use Cloud Build for this, yeah, and it's in the repo, yeah. Yeah, do you have a question?
So my question is, like it's very similar to his question about like serious machine learning models. So my question is, okay, now I know that, okay, serverless architecture is there, infrastructure. What about I have like a specific inference server? Can I plug and play that in terms of making that serverless, or no, maybe not? That might not be that easy.
When you mean specific inference server, what do you mean? Like what do you have now?
Right now, let's say I have like all the code for, except the auto scaling. I have everything that you require for a server to do the inference, and can I use this for auto scaling and other than like also the front end side? Yeah.
So kind of going back to the Cloud Run thing, as long as whatever you have can listen on an HTTP port, Cloud Run will be able to run it. You may have to put a Docker container around it to get like whatever your native libraries or your TensorFlow system libraries are. But Cloud Run on GKE or not should be able to do that for you.
Handle that. Okay, cool. Yeah, it can listen on HTTP and also gRPC things.
So gRPC is currently only on the GKE version of Cloud Run, but it should be able to do gRPC. But if you do over HTTP, Cloud Run takes care of like giving you the SSL cert, giving the URL, scaling it up, scaling it down. You just have to give it a Docker container.
Cool. Got it. Thanks.
Yep.
Hi, my name is Ravi, and I'm from Salesforce. I have a question with the cloud security that you showed. So you did mention that like a service can actually be blocked from calling another service. How does that work in multi-cloud or hybrid environments? Like when a service from a different cloud or an on-prem service is trying to call into your GCP service? Yeah.
So the question is, how does auth work if the service I'm calling is running elsewhere? So the auth here is all wrapped around. It's based on GCP IAM roles. So probably you would have to do something custom for that. It's something we're working on to have like a more general purpose auth layer in front of, like sort of a cloud endpoints-ish. But for now, it's just GCP IAM roles. So You would have to work around it, I think, unfortunately, yeah. So, yep.
Hi. Excellent demo. Thank you very much. I was wondering if you can share with us a bit info regarding Google Duplex and whether Google Duplex is going to be added to this ecosystem here, you know, being accessible through APIs, or is it going to be behind DialogFlow? Or
I have no idea. So Duplex, you're talking about the intelligent assistant that like will make calls and do reservations on your behalf. Yeah, I don't know. I think that's sort of outside of the Google Cloud Platform product group, so I unfortunately don't have any insight into that. Sorry. Yeah.
thanks.
Yep.
Hi, thanks for this. This is wonderful. I had a question about the asynchronous flow that you had. So you had Cloud Functions going to essentially PubSub, and that PubSub would essentially manage the latency that you'd have in whatever the Cloud Function was calling. How would that work for something that's longer latency? So let's say, I mean, the one that you had there was pretty quick. What if this was some kind of a BQ load job or some kind of, you know, something that you would want to be able to monitor and you know, be able to absorb that sort of latency? How would you do that?
So I don't know if this directly is what you're asking for, but there's another thing called Cloud Tasks, which is sort of similar-ish to Cloud Scheduler in the sense that you can queue up jobs, but you can give them like more specific things, like you can control. So PubSub is blast all the things as fast as you can, as many as you can. Cloud Tasks is much more like you can set throttling thresholds, like, oh, I know that I have some back system that like has some capacity that I don't want to exceed, so like don't go above this, don't go above this level. You can have it say like run these jobs at these specific times. So Cloud Task is a great tool. I did not put it in this demo because it only just got ability to make HTTP calls. It's like in alpha, and it sort of just happened. So that could have also been a good fit instead of PubSub for some of these, for things where you really need to control like throughput and specific timing rather than scheduler, which is like on like a rhythmic time rather than a specific time, or PubSub, which is just like go as much as you can, as fast as you can, as big as you can. So Cloud Tasks might be.
So in that you would essentially do regular polling and then put it back on the task queue if it wasn't done yet.
Yeah.
So
yeah.
from that monitoring. I had one more question, sorry. So I've done a lot of work with Data Store and App Engine, and I know all that is being migrated over to Firestore now. Will Firestore have the ability to do bulk loading? Because that's one of the big detriments of Data Store.
Yes. God, I hope so. I mean, I've run into it as well. I can't speak to roadmap specifically, but the ecosystem's already starting to develop tools around it because it's just kind of a clear need. So personally, I would guess so, but I don't know. I don't have insight into their roadmap specifically. Yeah.
Great, thank you.
Yeah. Mm-hmm.